Good morning, everyone. My name is Afreen. I'm of CSIT A section. Today, I'm going to present my topic Prepositions as Type. Introduction. Prepositions as types is a concept in computer science and mathematical logic that establishes a correspondence between logical prepositions and types in the programming languages. What are prepositions? Prepositions are statements that can either be true or false in the context of programming. Prepositions can be thought of as a type. A type is a set of values that share a common structure and behavior. Similarly, a preposition is a set of logical values that share a common structure and behavior. In other words, prepositions are types that represents logical values. Prepositions can be used in programming languages that supports dependent types. In these languages, prepositions can be used to specify the behavior of a program. For example, a function can be defined to only accept inputs that satisfy a certain proposition. This helps to ensure that the program behaves correctly and avoid errors. Types of prepositions. Prepositions can be classified into different types based on their structure and meaning. Understanding the different types of prepositions is important in order to use them effectively in logical arguments. Conditional prepositions. Conditional prepositions are statements that relate to events or conditions. They are usually expressed in the form if A then B or A implies B. Disjunctive prepositions. Disjunctive prepositions are statements that represents two or more alternatives. They are usually expressed in the form of either A or B or A or B. Existential prepositions are the statements that assert that existence of something. They are usually expressed the form they exist such as exist as a exists as such a such that b or some a or b. Preposition logic is a branch of mathematical logic that studies the logic relationship between prepositions or statements that can be either true or false. It is an important tool in both mathematical and computer science as it provides a formal language for expressing the manipulation logic statement. Logical connectivities. A preposition logic uses logical connectivities to combine two or more prepositions, such as into a more complex statement. Some common logical connectivities include conjunction and disjunction or negation not, implication if then, biconditional if and only if. Truth table. One of the key tools that preposition logic is a truth table, which is a systematic way of determining the truth value of compound proposition based on the truth value of a component proposition. Truth tables are particularly useful for evaluating the validity of arguments and constructing proofs in propositional logic. In propositional calculus, truth tables are used to determine the truth values of logical expression. Truth tables list all possible combinations of combination truth values for the proposition involved in the expression and then determines the truth value of the expression for each combination. Truth table lists all possible combinations such of truth values for a proposition involved in the expression and determine particularly useful evaluating the validate argument and constructing proofs of proposition logic. Proposition calculus is known as a propositional logic. It is a branch of mathematical logic that studies the logical relationship between propositions. It deals with propositions that can be either true or false and how they can be combined through logical operators such as and or not. Logical operators. Prepositional calculus uses logical operators to combine preposition in order to form more complex propositions. The three basic logic operators are and represented by upside down V or represented by V, not represented by dash. Variables. Prepositional variables are symbols used to represent prepositions. In preposition logic, they are known as prepositional atom or preposition letters. Preposition variables are typically denoted by lowercase letters such as PQ and R. Each prepositional variables represent a preposition which can either be true or false. Prepositional variables are used to construct complex preposition using logic connectivities such as and, not, and or. Prepositional variables are also used to represent the truth values of preposition in the truth table. Tautologies and concatenations. Tautology are important in preposition logic because they are form of basis of logical equivalence. Logical equivalence is a relationship between two statements that means they have the same truth values for all possible truth value assignments on their to the assignments to their prepositional variables. Any statement that is logically equivalent to a tautology is also a tautology. Contradiction Contradictions are important in proposition logic because they allow us to provide the that a statement is false if we can derive a contradictions from a set of premises, then we know that at least one of the premises must be false. This is known as the proof by contradictions. Logical equivalence. Logical equivalence is a relationship between two propositions that have same truth value in the possible scenarios. In other words, they are either both true or both false. Their relationship can be simplify complex proposition and make them easier to understand. Truth tables. Truth tables are useful tools for reasoning about prepositions. They allow us to determine the values of complex prepositions based on the truth values its component preposition. Conjunction and truth is equals to and false is equals to false and true is equals to false and false is equals to false. Disjunction or true is equals to true for or false is equals to true or false, or true is equals to true false, or false is equals to false. Negation not true is equals to false, not false is equals to true. Proofs are used in a propositional logic to establish the truth value of a proposition. A proof can be direct proof, a proof can be contradiction, or an indirect proof. Proof by contradiction. Proofs by contradiction are used to prove that the true value of a proposition by assuming the opposite of the proposition and showing the leads to contradiction. Example: to prove the proposition P is true, assume the P is false. Then show that the assumption leads to a contradiction. Since the assumption is false, P must be true. Applications of preposition logic. Preposition logic, also known as sententional logic, is a branch of mathematical logic and deals with proposition. Relationships. It is a numerous application that various fields includes but no are not limited to. Computer science. Preposition logic is used in computer science to design and analyze digital circuit programming, verification, and artificial intelligence. It is also used in development of programming languages and compilers. Predicate logic. Predicate logic is also an extension of a propositional logic that allows the more complex statement to be made. It introduced the concept of predicates, that a function that take one or more arguments and return a true value. Predicates are quantifiers. Predicates can be combined with the quantifiers to make statements about set of objects. For example, the universal quantifiers for all can be used to make statement about for every object in a set. For all x p of x, for all x p of x, p of x. Similarly, the essentials qualifiers are exits can be used to make a statement about at least one object in a set. This exists in x such as p of x. For all of x p of x. Quantifiers. Universal quantifiers. The universal quantifiers denoted by the symbol A, upside down A, expresses that the given condition is true for all the elements in a set. For example, for all x, p of x means that the predicate p of x is true for all the x in the set. Essentials quantifiers. The essential quantifiers denoted by the symbol E expresses that their existence at least one element is the set of satisfies a given conditions. For example, E of x, P of x. It means that exists that at least one of x is the such set such that the predicate P of x is true. Robotics. Propositional logic is used in robotics to design and control robots as well as the reason about their behavior and interaction with the environment. Mathematical proposition logic is used in a mathematical to study logic relationship between proposition as well as the development mathematical proofs and theories. Conclusion. Preposition as type is a powerful concept that are revolutionized by the way of thinking about programming languages and their applications. By treating By treating a preposition as a type, we can use the type system to ensure correctness and eliminate many common programming errors. This approach has been used in a variety of programming languages and has led to significant improvements in software development. As we continue and explore the possibilities of prepositions as type, we can expect to see even more exciting developments in future. Thank you.